Welcome, everybody. My name's James Cook, and welcome to AZ Community Roundtable. This is episode 3, and with me today is Jake and Olivia. I will pass on to Jake to introduce himself, and then we'll move on to Olivia afterwards. So I'll hand you over to Jake.
Yeah, thanks, James. Really nice to be on with you. My name is Jake Walsh. I'm a consultant. I work predominantly in the Microsoft Azure, IaaS, PaaS, sort of infrastructure as code space, based in the UK. Predominantly working with kind of mid-size companies. I work for a company called CDW, and yeah, just looking forward to this, having a chat and talking about lots of different things.
Brilliant, Olivia.
Yes, so my name is Olivier. I'm based in Amsterdam, but I'm from Paris. I work currently for TomTom for the infrastructure service, and I work in the hosting industry and also as a consultant for big and small company around Europe and even in US.
Brilliant, thank you, both of you. So from the introductions, and if you've recently seen my posts, I post a lot on infrastructure as code, as you heard from Jake and Olivia. They do a lot with regards to DevOps and infrastructure as code. So actually, we had a little bit of a cross-topic conversation. So we are going to focus today's podcast on infrastructure as code. So what I'll do is I'll bring up the first topic, and it may just slide off into other people's topics and overlap into there. So we'll just take it from there. So my first topic I'm bringing to the table is testing infrastructure as code. So I've been over the last few months doing a lot with Golang, using Go language to write my testing of deployments. So I prominently do Terraform, and what I've been using Go language is to run the builds in a test environment. From there, I then run some prerequisites to check that the resources created, if built as per the configurations I specify, check some ports and anything, if there's anything networky wise, and then I destroy it afterwards and then output a report in some way or form. So my question to you guys is, what actually it'd be like, what infrastructure as code tool do you use to write your to deploy your resources in Azure, and what type of testing do you do, if you do any?
So for me, most of the work I do is based on Terraform. I have to confess I'm quite new to the world of infrastructure as code. I'd sort of used ARM templates in the past and PowerShell, but sort of getting comfortable with Terraform was the sort of first time I ever thought, wow, I could see myself really getting into this, and I have kind of taken to it. It's been really good, actually. Sort of over the last 18 months, I've really taken to it and started using it a lot more. I guess traditionally for me, most of the deployments that were done sort of where there was a need for testing and sort of trialing things beforehand were done in Azure DevOps, but more recently been using GitHub Actions. Very simplistic for me, though. I think compared to what you've said, it's for me it would be perhaps having an action that deploys into production and another that deploys into test. A lot of what I do for my role is testing things prior to a customer deployment, and it's not always like a CI/CD approach. It might be, let's test this because we need to fulfill these business requirements with this solution, and in some cases that's not then going to be taken into a sort of continuous integration, continuous development environment. It might just be a one-off deployment or something. So I do tend to vary my approach, but yeah, for me it's Terraform and GitHub Actions now predominantly.
Okay, for me it's a bunch of Terraform because it's mandatory in the company I work, but I use also ARM templates and Bicep, a lot of Bicep because it's the new tools for infrastructure deployment that is given by Microsoft. In for testing, I used it not so long ago I used it Chef and Test Kitchen, which allow you to deploy a solution end to end and test the entire environment. But now I use mostly a test subscription, and I have some pester tests that help me to create a testing solution that I can check in Azure DevOps, because Pester is a PowerShell unit testing tool. Pester can generate you test unit format that you can display in Azure DevOps pipeline after the pipeline execution.
That's interesting. So both of you sounds like both of you do exactly the same thing. The same that I was doing initially. So initially, like you say, having multiple maybe subscriptions or multiple locations in a subscription, for resources to deploy initially just to test. And again, both of you are using Terraform, so it does make sense. And this is what I've been doing. What the idea of my testing was that rather than just deploying the resources, the questions I've had from colleagues and I've had read articles where deploying infrastructure as code is fine when the deployment is completed, you're relying on Terraform to basically output that everything's correct and you manually check in. And the idea of using something like Go language to test the resources have actually created, other than relying on just Terraform, and also created based on your configuration and working as expected, that was the language to use. I think that's because Terraform also is built on Go, from my understanding. So it uses Go language itself. So yeah, that's what I've been doing the last couple of months is literally building test modules using Go language that basically runs the build via Terraform, and then there's just some Go code to just basically just check that resource is created. Is it created with the correct naming convention? Is it running as expected? If it's like a static website, is it open on the correct ports? Yeah, is the network security group got the right rules in place? Yeah, as part of that deployment. And then after that, it just destroys it. And it goes off into our separate development subscription. But the idea would be that rather than it staying up and running, it's actually just going to go off, build it, and destroy it once it confirms that everything works as expected. So yeah, it's quite interesting that you guys are basically where I was a few months ago. I was still doing that because it's a lot of work in regards to actually coding these test files. You think how long it takes you just to write the config files to deploy into Azure and put it into each environment to test, but then actually writing test files afterwards, it's a big overhead.
I think you make a really good point there, though, about and kind of this sort of automated testing would have been very, very challenging if, for example, let's say you were writing a deployment into an on-premises environment, and that was, you were going to then try and deploy that for 10 different customers or 10 different use cases. You would, in theory, there have 10 different environments you were going to try and deploy and test again. And this is kind of one of the things that's really changed with public cloud, is you now have a platform that is fairly universal, in the sense that the platform for customer A and deployment A is the same as the platform for customer B. So all of that testing and all of that sort of effort you put in, okay, it's still effort and time, but it's it provides you with something you can reuse, you can do multiple deployments on, you can spin it up, test it, destroy it, you can spin an environment up and attempt to break it. You can do all sorts of extra things. That's something I've been testing out recently, actually, using some of the scanning tools in GitHub Actions to actually scan the code pre, post, during deployment, whenever you want, really, for security vulnerabilities and those sorts of aspects. And it's, that's kind of the holy grail, isn't it? Prior to a deployment, if you could have somebody tell you, well, actually that, there's a security problem there, or you should do this to make it more secure before the environment is even deployed. So all of that kind of automated testing is certainly bringing a lot of power, to this kind of area.
Yeah, that is actually interesting.
Yeah. About testing before deploying, with ARM templates, I've started to use the what-if solution. What is missed in ARM templates when you look at Terraform is what will be changed, what will be deployed, and what will be modified by your solution. And having this option, which is a simple switch in your command, lets you to see what happened, but it lets you see exactly if you make a mistake, because it's very easy in infrastructure as code to make mistakes and to end with a non-working solution for the customers. It's very, very easy. But I didn't know if there is a real scanning solution for ARM templates. I should test to see if there is one. I know that there is some tools in the language to see, for example, if you have a secret or certificate in a plain text in your templates, which is something you should not do. But I don't know if we have such a solution. I think yes, but I should try to see if we have more data for that. It's a good point.
One of the things that's really interesting, just on that that sort of method of deployment, the what if that you mentioned, is I've done some deployments recently for a customer where I've sort of written the code, and I've actually deployed the environment multiple times in my own test subscriptions prior to the customer deployment. So instead of for example, let's think back to a traditional IT estate where you might have turned up to see a customer with some boxes, some disks, and you would have sort of racked and stacked the kit, you would have built them, whatever the environment may be. Whereas now I'm actually able to build, destroy, tweak their environment multiple times, so that when I actually go and do their deployment, it's already been through all of the initial testing, anything I would need to iron out in terms of issues. And it's making things quite interesting, because it's sort of you're actually able now to test an environment much more when it's in code, because you can deploy it in your own test environment. It's also really useful. I've actually used the exact example you gave about what will be changed, what will be modified, what might be destroyed when I've been asked to go and fix an environment that's been built. So I've actually re-looked at the code that I used to initially deploy an environment, and actually just rerun something like Terraform plan, for example, and I can then get an idea of what's been changed. So it's really powerful. It's for me, it's been really interesting. I actually now prefer to work in the command line, whether it be something like Terraform, whether it be the Azure CLI, than I do to work in the portal. And I never thought, if you asked me that question a couple of years ago, it would have been a different answer. And now, just from the perspective of repeatability, I can test something in my own environment much more easily. And that aspect of, if I write something and I can, let's take Terraform as the example, I can run plan, I can output, I could do a graph, I could test it in my own environment. It gives that confidence. And I think once you actually get confident with using the sort of IAC concepts and whatever, whatever tooling you choose to use, you actually start to feel, that you're much more empowered than you would be if you were sort of pointing and clicking in a GUI or something like that.
And also, I'm testing the deployed environment, because when you have the solutions in your pipeline, the solution is based on parameters, the variables for the customers. For example, if you deploy a landing zone, this parameter should be IP prefix, name of resource groups, etc., etc. And sometimes you can make mistakes with these parameters. You can, for example, have the wrong IP address, have the wrong name, etc., etc. So I start to integrate in my pipeline a test, a pester test based on PowerShell to see if what is deployed is what I wanted first, but what is deployed work as expected too, to be more confident in our pipeline, to see that if there is a mistake in the parameters, we know it quickly. And so we will not say to the customer, okay, it should work, start working with your new environment, and the customer come back, oh, it doesn't work. No, we know that it doesn't work before sending the message to the customer. And it's great because it makes people more confident of using automation, using pipelines, and using tools that we create for deploying solutions in Azure.
And that's an interesting point because we've all been using the word automation, and I think, like you say about, I think the automation gets talked about quite a bit in regards to speeding up and less resources, and how we've been using the word is actually been how we create scripts and the code and testing before it actually goes live. And that's what we're building, that automated process to be able to turn around to a customer and be able to say that reliably that's going to work, or it's going to whatever we're deploying, we know certain things is not going to work because we've done this already in the testing environment. And to me, where we've used the word automation, automation, that we've been able to actually not use it to define, oh, we're using less human resources, everything is going to go, it's just going to be reusable to that extent. Actually, we're saying that literally that everything beforehand is ran over and over and over again by ourselves, and we then put in that process that one last time live, and it will work, and we can run it like Jake said. You can run a plan again against an environment 6 months time, a year's time, and actually see what's changed if someone's done something outside of that IAC repo, for example. And that's actually another question I have for Jake, maybe. Seeing that we all use infrastructure as code, and that's probably all of our preferred method to working within the Azure. What's your view on other people doing stuff that's outside of infrastructure code, that is playing around with resources that you configured in infrastructure as code? So, for example, my policy to my colleagues is, if I've deployed something by infrastructure as code, I expect them not to touch anything in regards to configurations in the portal, and I expect them to do it via infrastructure as code, so that when I do run a plan, I do not expect it to flag up any configuration changes. And if it does, then I would be looking back at the logs and seeing what has triggered it, because usually when that happens, I would suspect that someone unauthorized has done it, or something has changed without pre-approval. I don't know what you guys think about working both in portal and infrastructure as code on the same resources.
I think that's a really, really interesting point, actually, because it's something that comes up time and time again. And the explanation I always use is, it's a bit like having a car with 2 steering wheels, 2 full sets of pedals. Imagine this strange imaginary car. And if you're driving down the road and you both get the wheel and both turn in different directions, you're fighting against each other. And it's kind of like that. I think it's sort of when you go down, the sort of route on a project, for example, where you agree that infrastructure as code is going to be the focus. I think there has to be a sort of agreement on the team, as you said, that this will be the tool set we'll use. I think it can be useful in some cases to point out, if you are working perhaps where you're deploying one application into a resource group that will be deployed using infrastructure as code, and somebody else is deploying something into another resource group that's perhaps being deployed manually through the portal, or they're using the Azure CLI or something, just to agree on what those boundaries are. So sort of say, this is the tooling we're using and this is what we consider the boundaries, and just let people know, say, okay, if you do realize if you go in and change this virtual machine, or you make a change to this resource, you run the risk of that getting destroyed and recreated when we rerun our code. And I think, as long as you're clear with the facts, it just makes sure people are aware. The other thing you can do, of course, is you could have, for example, a number of people working on a pipeline, or committing code to a repository, and you could actually have the deployment of that so it's only possible through your pipeline, and simply don't share any other details. So, for example, if it was in Azure DevOps, people could have access to the repo to commit their code, but they wouldn't necessarily have access to the subscription. There would be a service principal in a pipeline that's controlled through permissions, and that would be how the deployment is done. That's a more extreme example, but if you don't want any changes done outside of your one piece of tooling, that might be an option for it.
Yes, and the problem here is very interesting because it depends what you deploy. For example, if you are in an infrastructure services and where you need to deploy, for example, a network object, VNet, or anything else like this, the VNet itself is on our responsibility, so it should not be modified. But the subnet, customer will be free to create some subnet, to create some NSG, to create NIC. So you have to be really careful in the solution that when you redeploy your VNet, you doesn't touch anything else, especially the subnet, to avoid any catastrophe in their production. But I have another case where we deployed an entire solution in a new resource group each time. This solution was based on several VM, and there is also a solution of infrastructure, not infrastructure as code, but configuration as code in this VM that was deployed with a single ARN template. So here we do not want that anything could be changed from command line or from the portal. We want to be sure that our repository, the GitHub repository, is the exact mirror of what we had in Azure. And for that, there is a solution. You can lock your resources. So when you lock your resources, it makes impossible to other customers to change anything by the portal. And when you want to redeploy or make modification, you will need to remove this lock, which and for that you will need to be the owner of the resource groups. So it can make you some protection, but it doesn't work well with VNet, for example, because people will not be able to change the VNet, or more with storage account. When you deploy your storage account, you want your customer to use it and to create containers. And if you lock the storage account, it can be a problem for that. But there is some solution, and it's very hard because sometimes the objects you are deploying can be changed by the customers so they can use whatever they want. And sometimes you don't want the subject to be changed by anyone except by your pipeline. So you need to have a solution. It can be a permission solution, or it can be a log solution.
Interesting. Yeah, I fully agree with both of you on that. I think it's a different perspective. I think I've got the ability not to, because I work in a internal company doing this type of stuff for development. So it's a bit different to customer facing and having to deal with how the customer wants their deployments done. Obviously, infrastructure is code, and then you've got some customers that will go, actually, I want to do something in the portal, or you may have some customers that want to do, like you say, use AZ CLI and do it through there and run scripts, alongside what's been done by Terraform, for example. So yeah, it's quite a good point. I think it's just one of those things you have to be quite flexible with, depending on who you're working with. So
that that sort of flexibility and depending on who you're working with is something that I encounter quite a lot as well. You know, working with different organizations, you know, naturally organizations are at different stages of their cloud journey. They're, you know, some organizations have sort of you know, gone into cloud, others are in the early stages, and you sometimes do have to vary, you know, how you're going to carry out deployment based on that. Sometimes, you know, for example, in my job, the deployment is one piece of the work, but actually some training is another piece. And you know, I wouldn't be doing my job properly if for example, I wanted to go into it. Let's say I was going into an organization and I was going to deploy some new virtual machines in Azure for them. Well, if I went straight in and came armed with my Terraform, ready to go, connected, logged in, did the deployment, done, you know, see you later. That would not be as good for a customer who was, you know, perhaps in the early stages and wanting to understand the key concepts, all of that sort of initial foundational items, as me actually sitting down with them and going through how to do something in the portal. So it's a really interesting balance, and it's something where I certainly see all sides of the you know, kind of options, and sometimes, you know, it's you're sort of thinking, well, I could do this in 10 lines of code, but actually what you're delivering there is more about, you know, delivering an understanding and delivering training rather than it is just doing a deployment, for example.
Yes, it's very true. Inside organization, teams are not on the same level. If I remember the previous companies where I worked, for example, we had someone in the United States that were really advanced, that use Terraform, that use um, serverless computing, Azure function. It was very great. And at the same time, other teams in the company in Spain just started the journey in Azure, and they cannot do anything if it was not in the portal, for example. So it's very important to be sure that you give your solution, but also give them some kind of training and some kind of understanding of what is Azure and how to use it. And sometimes it's very hard because they will mirror what they have on-premise in Azure, which is generally not a good thing to do. And you have to be very careful about that.
brilliant. Jake, because we've sidetracked quite a bit, on each of those topics, and like I said, we're all talking about infrastructure as code on this session. Is there anything specific that you want to bring to the table?
I've got I suppose it's a feeling that's developed over the last few months, but for me, I can't see infrastructure as code not being the future. I think as we progress over, you know, the next sort of 6 months, 12 months, 2 years, whatever it might be, I think the vast majority of people working on large scale cloud projects, particularly people in roles like myself, where I work with, you know, multiple different customers, for me, infrastructure as code is absolutely the future. And I'd just be interested to hear, you know, alternative views on that, or if that's a common feeling in the community.
From my viewpoint, I think I can't really say that it's not, because in a few weeks' time I'll be moving into a development operations engineer role full time. So my role will be to prominently look at doing everything as infrastructure as code and using continuous integration, continuous deployment. So it is one of those new. We know DevOps has been around for quite a few years, but it's still a lot of companies are still catching up with that practice of working. But infrastructure as code comes into it, and yeah, I can't see there being any change to how people foresee it like yourself. I think it's the future, but it's the future now in regards to how people are going to adopt it. It's how is it just infrastructure though? So I've been doing a lot of research recently on using Terraform to deploy repositories and setting up workflows and permissions and everything in GitHub. So I wouldn't class that as like infrastructure, but it's actually setting up a bit of software to act in the same way. And there's so many other things that Terraform can work with, like DNS providers and stuff like that. And you can say DNS is infrastructure. There's other things you can do with it, Terraform, but it's how it's not just that one particular area in regards to like cloud infrastructure. It's also doing other things in regards to like CI/CD. So it's the way I can see it being adopted even more. I think I've seen a recent. I don't think it's even recent. I think it's been around about a year or so now. Grafana monitoring, so setting up dashboards and monitoring through code through that as well. So it's becoming, because Terraform is designed to be multi vendor based. Yeah, what in comparison to Bicep at the moment and other like ARM templates. It's becoming more. It's been adopted more by the community, and I keep on seeing. You got on HashiCorp Terraform, you have I think they call it the marketplace. I'm calling it the providers marketplace, and you have the ones that they provide providers for. You have verified providers, which are usually like Microsoft and Amazon, and then you have community providers where people in the community have used the language, and I think it's Go, to then build their own providers to then talk to that software. So it's ever growing, and I keep on seeing loads of new concepts of new tools. So we had Bicep that came out. I think it's been worked on for a couple of years, but I think it officially was released this year. We know of Terraform and Pulumi. I think one's called Lollipop as well. I'll call it Lollipop. It might be completely and utterly wrong. But there's quite a few CI/CD tools, and a lot of them are based differently based on how people work. So Pulumi is multi-language supported, and Terraform just a few months ago started supporting, I think it's Python as well. So you can now do Terraform coding language, use HCL language as one option, and you can use Python as the other option to code. So it's pretty interesting how it's adapted over time, but literally it's ever growing, and I can only see it going much quicker in the next 6 to 12 months. I can see it being adopted more. I can see more content, a bigger push. But yeah, I can't see it going backwards, and I can't see it just staying as it is now. So
I completely agree. That's another interesting point, actually. Is I don't know if anybody else feels the same way as I do, but keeping up with the rate of change in in the cloud industry is a challenge in itself. But even looking at certain tool sets and some of the infrastructure as code, conventions, tools, products that are out there, it changes so rapidly, and that kind of pace of development just really shows how many people have taken to it, and there probably is a really good future in it.
Yeah, I would say yes that infrastructure as code is evolving, and more and more people want to use it. But it's part of the modernization of our application, the modernization of data centers. It comes with configuration as code. It comes also with pace services and observabilities. All the tools you mentioned, for example, Grafana, but other tools. And more teams are adopting this philosophy and to deploy their application. And the application is not only the code and the executables they have, it's the entire solution with the infrastructures, with the cloud objects, and their application. And that's why we will have more and more tools for infrastructure as code. That's why, for example, Microsoft is working on the modernization of ARM templates with biceps, but also with template specs. And we will see soon new tools. For example, just started to learn Pulumi. I'm not sure to pronounce the tool names correctly, but you can embed your configuration as code and your infrastructure as code as in part of the development, because you can write your infrastructure as code in .NET or in Python, and it's very powerful for teams because they do not need to understand new languages, Terraform or ARM. They just need to use their own languages to deploy their solution in Azure or in AWS, for example.
Yeah, it's interesting, and about how many, like you say, how many, like I've mentioned, you mentioned multi-language support, and like Jake said, yeah, literally, it's ever growing and trying to catch up, keep up with everything as well. And with Terraform introducing another language, it gave me a little bit of a fault and in some ways a worry. If you start introducing more languages into a specific tool set rather than just the one, does that open up risk to people or I should say teams you're working with multiple languages, and then having, when you're looking at recruitment or keep your own self-paced learning, you have to probably learn multiple languages to be able to read what other people are writing. So, for example, like Terraform, yeah, with HashiCorp configuration language, I think that's what HCL stands for exactly. But literally, that's quite simple to read, nice and easy. Off you go. Python, if you don't have, I would say, basic coding language in regards to Python, could you look at that and understand it and write or amend it? Honestly, I don't know, because that's not come to me personally to then go, okay, yeah, I can't look at that, I can't read that. I can read Python and write Python configurations in Terraform. Are these providers trying to cater to too many people now? That's another question to you guys. Do you think multiple languages in a tool could cause more problems than actually fix anything?
I think it kind of having choice is good, because it then these tool sets will appeal to more potential users, and it gives people from different sort of skill backgrounds can use the tools. I think for me it's you've exactly hit on the point there around one of the reasons I really like Terraform and the HashiCorp configuration language is because I can look at it and, okay, I'm not saying, if there's a huge file with, line after line of code, I'll know everything that's going on, but I can get a good idea of it. And once you get comfortable using it, you can do that quite quickly. And for me, that's another great reason. It feels comfortable in the same sense. To be fair as well, Bicep's made that much more accessible, much more easy to read. And the way that's developing is really quite exciting as well.
The main question, I think, is how to onboard most people. There is people who do not want to learn a new language. Let's say they work on .NET, they want to work only on .NET, they do not have time to learn Terraform, Iron Template, or Bicep. If they can do the deployment directly in the language they know, is good. We may have some other solutions. We may have some other infrastructure as code tools, but the more you have, the larger the public you will have, and it's good because infrastructure as code, as we say, is the future, and we can imagine, for example, having a tool or a language that will use infrastructure as code, but with machine learning or artificial intelligence to create your solution. So yes, we have in the future we will have more and more tools. We will have maybe more and more languages. I think that having more tools is not a danger or not something. It just helps to have more and more people working in a good way in the cloud.
Yeah, definitely. I can see the viewpoint on that. Yeah, definitely. Olivia, have you got anything to bring to the table?
Yes, I will want to share something because in my current job and my current task, sometimes I have to share templates, but it will be the same with Terraform or any other solution. I want my team to be responsible for what they are doing in Azure. But at the same time, I want them to do specific things. If I want them to, for example, create a DNS resolver, I want them to deploy it in some way. If I want them to create backup solution, I need them to follow the standard of the company. So how can I share my templates with all my teams? It's something that is really difficult because you have several options. You can open a repository on your Git environment, and your teams can download the templates. But as we say, not all the team are on the same level, and it can be difficult for them to deploy them. And by the way, how do you manage the versioning of this template? It's very difficult. And this is why Microsoft created the template spec. Template spec allow you to have a sharing space in Azure where you can download your templates. You can put some versioning inside, and also you can use Airbake to allow or not user to use it. So people now with template spec can deploy standardized solution from Azure directly in their own template, and it makes things more easier for everyone. For the customers, it's simple. You just have to read the documentation, create a link to the template specs. It's just the ID of the templates and the version. So it's simple for you, for if that in this template is very simple to you, are working on this either with the Python or manually, and it makes things really, really simple.
That's interesting. So the templating function in Terraform is modules. So I create modules where I can so that they are reusable. When I update modules, I usually have a comment area in my module where I just amend the versioning number. Don't know if that's the right way to do it. So what will happen is I don't replace the file with a new file. It's just in place replacement with a new version number. It means if there's something wrong with that particular module, once it's available to everybody and they try anything wrong with it, we can roll back on the repo to a older version of that file with the specific version number in the line of code. So that could be right. I could be doing it wrong. It could be that it's not wrong, but there could be a better way of doing it. I do agree with what you say as well in regards to an actual library function. Obviously, ARM templates have that in Azure, and something that is missing in Terraform. I don't know about the Terraform Cloud version. I'm thinking there might be something now. And I think that's something, yeah, that obviously if you pay and are a commercial user, you might have access to it, that function. But with the open source version, I don't think there's any other way than doing it via repo. And I think that's the best, it's the only way and the only, and it's the best way to do it. From my knowledge, I have looked at other options. I think what did I do initially before I did a repo? I used to share the files in a SharePoint in Microsoft. The worst idea ever, but it was the idea was that it was a shared library, not to be used as a location to the deployments or anything, or anything other than that. But it was an idea that you take your template through there and then rewrite your code. But we learned from that that was a really bad way of doing it. So using repos was the only way and the best way to do it. I don't know what your thoughts are, Jake, on that.
Yeah, I would definitely say certainly if it's Terraform, I probably would just go down the repo route. The template specs in Azure is a really interesting one as well. And I think it's one of these where you could probably approach the problem with 10 different solutions and probably have 10 successful outcomes, but it's kind of measuring what works, perhaps what tooling you're already using, what you're comfortable with, and just sort of going from there really. I think I would probably be in the use existing repos and use that to sort of do the version control and go from there really.
Would you say would you version? How do you version control like your modules, for example, Jake? Do you actually keep the existing file and just like I do comment what version it is, or do you actually make a copy of the file, version that new copy, and just keep the old one as historic in the repo?
I go for the latter, so I prefer to have like a history. Traceable history of the modules, purely because I am risk averse and I'm trying to make it as smooth as possible. I guess the problem with that is if I've got to remember to update any existing code to point at the right modules or whatever it may be, that there's obviously an element of potential human error there. But certainly if you're sort of wanting to test something and move forward and back, that would be the approach I'd go for. That being said, once you've finished with something, perhaps you're going to make a copy of that for another deployment or move it elsewhere. Perhaps you don't need to take all that historical information with you. You can just keep the current ones if they deploy successfully. just so it's a little bit cleaner. But sometimes being able to, go back and check how things were done previously is a useful point of reference as well. If you might have updated a module for a new convention or a new way of working, and actually having a piece of referenceable code that you could go back to for for any need you have to recheck something, redesign something, or see how you previously solved a problem, that can prove useful as well.
Sorry, I will add also something, because if you look at the development of Azure Biceps, you see that now it's in a production grade version, so you can use it for your production environment, and it means that you can have the Azure support in case of any problems. But I should try to share the link about the what's coming with Azure Biceps, because there is a lot of new things that are currently in development, and we will see in the next weeks and next month new tools around Azure Biceps, and it will be very, very. I will try to share the video on YouTube about that. I will try to share it in the chat if I can.
Yeah, that's fine. We'll keep an eye out for that, because that sounds interesting. Because like you say, Bicep has a lot of new features coming out, and initially it was thought that Bicep would be like a like-for-like comparison to Terraform, but actually Bicep is coming out with a lot of new ways of doing deployments and writing code for infrastructure. And a lot of the struggles we do have regards to Terraform, it seems that Microsoft's for it when developing Bicep. So it is exciting times, but it's one of those another considerations we have to look at in the future. Like we said, there's multiple infrastructure as code tools coming out, and hopefully once, like for example, Bicep comes out with some of these new features, the likes of HashiCorp will look at Bicep and go, okay, what we'll do is we'll copy what Microsoft did with it and then start incorporating it in our tool. That's what I hope. I hope there is a bit of copycatting going on that will develop, because if I see a feature in Bicep and I go to myself, oh, I really want that feature, HashiCorp Terraform doesn't have it, do I actually look at moving myself over to a new tool? And I don't like that idea. It's bringing back to the days of software vendors. It's sort of listed software vendors. I'll use I like using Adobe, but I'll end up using another video editing tool because it's got more features. And then once I go to that one, a year later, that's behind, and I want to go to another software provider. So I hope that these big organizations copy each other. I know it's a bad way of thinking it, but literally, if they can learn from each other and copy the good features that are there, hopefully we should be able to stick with a specific provider that we feel comfortable in. But yeah, Bicep are coming out with. I think I saw a list yesterday, and it was coming out with a lot of good features.
And having that commonality between different tool sets is really good as well, because if you're, let's say, for example, a number of different people have, one person wants to work in Terraform, somebody else wants to work in Bicep, somebody else wants to use another tool, then having the ability to do the same things in different tools is just going to mean more people can use a platform. It's, it acts as an enabler. More people comfortable with different tool sets can consume the same platform. It can only be a good thing, having commonality between the tools and allowing different methods of usage and integration.
Brilliant. Okay, so I think we're going to wrap up. I don't know if Jake or Olivia have anything else to say.
Nothing from me, no, just thank you. It's been a pleasure.
Thank you, yes.
Brilliant. Thank you for coming on and talking infrastructure as code. Is actually my favorite topic to discuss here when we talk about the cloud. So thank you for coming on, and thank you all for listening. Our next episode will be arranged at a later date and will be shared on Twitter on AZ Roundtable. Have a good evening. Speak to you soon.
Bye-bye.
Cheers.